Hello everyone, welcome to my YouTube channel. Today we're going to discuss about paper 41, May-June 2023. This is IGCSE paper. Uh, in today's session, we're going to discuss about the paper question number 6 and 7. So this question is about the sulfur and its compounds of the sulfur. Sulfur is converted into the sulfuric acid by the contact process and the process involves four stages. So these are the four stages for the formation of sulfuric acid in the chemical industry. Uh, the first stage is molten sulfur is converted into sulfur dioxide. You know that this is the equation that sulfur. It reacts with the oxygen or the air to get sulfur dioxide. Sulfur dioxide reacts with the oxygen to form sulfur trioxide. So this is sulfur trioxide combines with the oxygen to make sulfur. This is sulfur dioxide combined with oxygen to make sulfur trioxide. This is the balanced chemical equation. You know, the specific some conditions that 450 degrees Celsius temperature and 1 to 2 atmospheric pressure and vanadium pentoxide as a catalyst. Then sulfur trioxide combines with the concentrated sulfuric acid. This is sulfur trioxide combined with the concentrated sulfuric acid, and the product is there, which is the oleum. Then oleum reacts to form concentrated sulfuric acid. Oleum combines with the water to get sulfuric acid. This is the chemical industry of the sulfuric acid. It starts from sulfur to sulfuric acid. Now look at the content of this question. In the stage 1, iron pyrite, FeS2, can be used instead of molten sulfur. So this is another raw material which is used to get sulfur dioxide in the chemical industry, except sulfur. So iron pyrite is heated strongly in the air. Balance the equation for the reaction occurring when iron pyrite reacts with oxygen in the air. Now, to balance this equation, just look at the number of atoms of each element. Like there are 2 irons, so if you put 2 here, now there are 4 sulfur atoms on the left hand side. You can put 4 here. Now iron and sulfur, they are balanced. But if you look at the number of atoms of oxygen on the right hand side, 8 plus 3, 11 oxygen atom on the right hand side. So if we put 11 by 2 here, then 11 by 2 times 2, we will get the 11. So to remove this denominator, we can multiply the whole equation with 2. So if we multiply the whole equation with 2, we will get 8 here, 2 coefficient here, then 11 here, and 4 here. So these are the coefficients: 4 before FeS2, 11 before O2, and Fe2O3 next to the 2, and then 8 before SO2. So these are the balancing coefficients used to balance this equation. Name Fe2O3 include the oxidation number of iron. If we look at the oxidation number of iron, we know that the sum of oxidation states in a compound is 0. Oxidation state of oxygen is -2. So the sum of 3 oxygen atom is -6 here. So if you multiply 2 with 3, we will get +6. So +6 minus 6 is 0. It means the oxidation state of iron in this compound is 3. So the name of this compound is iron 3 oxide. 3 is the oxidation state of iron. The next part is that the equation for the stage 2 is shown. This is the equation of the stage 2. We have already talked about this equation. The forward reaction is exothermic. This is exothermic. It means the reverse reaction is endothermic. And if the forward reaction is exothermic, then the overall enthalpy change is negative. The overall reaction is also exothermic. Now, these are some specific conditions like temperature, then pressure. Using expectation that do not involve cost, explain why the temperature greater than 450 degrees Celsius is not used. Now, this is the specific temperature or optimum temperature for this reaction. If we increase the temperature above 450, what will happen? The forward reaction is exothermic and the reverse reaction is endothermic, so equilibrium shifts to left. if we increase the temperature, or if we use the temperature which is greater than 450 degrees Celsius, what will happen? The equilibrium shifts to left. When equilibrium shifts to left, the yield of the sulfur dioxide decreases. Okay, so we can say that equilibrium shifts to left, so yield of SO3, sulfur trioxide, decreases. So that's why we're not increasing the temperature more than 450 degrees Celsius. Explain why the pressure lower than 2 atmospheric pressure is not used. Now, 1 atmospheric pressure, or the 1 to 2 atmospheric pressure is used. Why a pressure lower than? If we decrease the pressure, what will happen? If we decrease the pressure, the equilibrium shifts from less mole to more moles, because when we increase the pressure, the equilibrium shifts from more moles to less moles. So if we decrease the pressure, what will happen? The equilibrium shifts from less moles to more moles. In that case, the yield of SO3, yield of sulfur trioxide, will also decrease. And the second thing is that if we talk about the rate of the reaction will also decreases. So rate of reaction, and both rate of reaction and yield of the sulfur trioxide decreases. So that's why the pressure must be high. If we increase the pressure, definitely the particle come close to each other and more effective or successful collision, so the rate increases. Or the equilibrium shifts from more moles to less mole, from left to right, and yield of the sulfur trioxide decreases. And if we use the less pressure, the opposite effect can be seen. Sulfuric acid reacts with ammonia, and the salt produced is ammonium sulfate. Write the symbol equation. Sulfuric acid is H2SO4, and ammonia is NH3, and ammonium sulfate. Ammonium is NH4 positive and sulfate is SO4 2 negative. So we will get a formula: ammonium sulfate NH4 2 times SO4. Then if you want to balance this equation, there are 2 nitrogen on the right hand side. So if you put 2 here, the rest of the equation will be balanced. So this is the balanced equation for the formation of ammonium sulfate. Then lead-2 sulfate is an insoluble salt. And you know that the insoluble salt is formed by the precipitation reaction. So lead-2 sulfate can be made from aqueous ammonium sulfate using a precipitation reaction. So this is one of the reagent, ammonium sulfate. And this is the ammonium sulfate, one of the reagent which is used to get lead-2 sulfate. This is the aqueous, because all ammonium salts are soluble. Name a solution that can be added to aqueous ammonium sulfate to produce a precipitate of lead-2 sulfate. So if you want to get a precipitate, we have to mix the two aqueous solution. As we know that all the nitrates are soluble, so that's why you should use the nitrate of lead. So if we use the nitrate, we will get the lead sulfate and ammonium nitrate. So the reagent or the reactant which is used to get lead sulfate or lead-2 sulfate as a precipitate, that is lead-2 nitrate. So this is the second reagent which can be used along with the ammonium sulfate to get lead-2 sulfate. Write an ionic equation for the precipitation. Whenever you want to write down the ionic equation for the precipitate, just copy the precipitate on the right hand side. This is the precipitate, lead-2 sulfate, and the two ions which are used to make this precipitate. Here, you know that the lead is Pb2 positive and sulfate is SO4 2 negative. So this is the balanced equation for the formation of lead-2 sulfate. The precipitate of the lead-2 sulfate forms in aqueous solution. Describe how pure lead-2 sulfate can be obtained from the mixture. Because the insoluble lead-2 sulfate is present in the aqueous solution, although this is insoluble, but you have some aqueous solution as well, because you are getting another product as well. So describe how pure lead to sulfate can be obtained from the mixture. First of all, if you want to remove this precipitate, you have to do the filtration. So just filter to get insoluble lead to sulfate. Then wash the precipitate with the distilled water. This is done because to remove the traces of soluble salt. So wash the precipitate with distilled water and then dry between the folders filter paper. So these are the three steps we use to get pure lead to sulfate. Look at the next question. And this question is regarding organic chemistry. Organic compounds butane reacts with the chlorine in the photochemical reaction. This is butane and this is chlorine. State the meaning of the term photochemical reaction. Photo mean light. So the reaction which needs or uses ultraviolet radiations or light, that is a photochemical reaction. And photochemical mean the needs or uses UV light. Ultraviolet light. So an organic compound with the formula this C4H9Cl is formed when the one molecule of butane reacts with one molecule of chlorine. So draw the displayed formula of the two possible structural isomers with the formula this. In structural isomer, uh, you have to draw the two possible structures of chlorobutane. So you can change the position of chlorine to get another isomer. For example, if you have four carbon, so here are the four carbon, draw another structure for carbon. So if you place chlorine on the first carbon or chlorine on the second carbon, you will get the isomer. Here, to make it tetravalent, you can add the hydrogen atoms. So these are the two possible isomers of butane, chlorobutane. This is one chlorobutane and this is two chlorobutane. You can also change the length of the carbon chain as well. I mean, if you want to make another isomer, you can put chlorine, carbon here and chlorine here. This is another isomer of this C4H9Cl. There are so many possibilities of the different isomers of C4H9Cl. The structure of the compound A is shown. Now, get this structure. There are different things like it contains double bond. The alkene is there. This is, the carboxylic acid is there. And then, so there are three functional group present in compound A: alkene, carboxylic acid, and alcohol. Deduce the molecular formula of compound A. You just have to count the number of carbon, hydrogen, and oxygen in this A. So this is C4H6O3. Name the homologous series of compounds that contain the following functional group. C double bond C is alkene. OH represents the alcohol and COOH represents carboxylic acid. State what is observed when A is added to. Now, this is the A, which contains alkene, alcohol, and carboxylic acid. So if A is added to bromine, bromine will can be used to test the presence of double bond. So bromine changes from orange to colorless, orange or brown, or you can also say yellow to colorless. And aqueous sodium carbonate is used to test the presence of acid. So carboxylic acid is there. So that's where sodium carbonate reacts with the carboxylic acid to form carbon dioxide. And this A will also produces some bubbles or some effervescence of carbon dioxide. And there is another thing that if we add the another alcohol, then that can also give us the ester as well, sweet smelling compound. Now, compound A can be used as a single monomer to produce two different polymers. Draw one repeat unit of the addition polymer. So addition polymer is due to the presence of double bond. So if we want to draw one single repeat unit, there is a double bond. So just remove the double bond. This is actually the A. This is A, which contains double bond. So if you want to make the one repeat unit of the A, just remove this double bond and extend the carbons which contain double covalent bond. So this is the polymer. Then compound A can be converted into dicarboxylic acid. The compound A contains two groups, carboxylic acid and alcohol, so that can be used to make ester as well. So whenever you got the ester along with some water or acid, that type of polymerization is condensation polymerization. So in the condensation polymerization, for example, this is the A. If you add alcohol, you will get the ester here. And if you add carboxylic acid, you will get the ester linkage here. So the name, the type of condensation polymer form, ester linkage, there are because there are many ester linkages. So that's why you can say this is the polyester. So this is all about the paper 41, May June 23, 0620. Thank you.